Dear friends, today I will discuss with you an application of the Gauss theorem. Gauss theorem that how we can find the intensity of the electric field at a point due to infinite plane sheet of charge. This sheet which I am showing here, it is of fineness, but actually the sheet under consideration is of infinite in dimension. The sheet is so thin that this charge which is appearing here, the same is visible on the other side of the sheet. So it is so thin. Now our problem is, what is the electric field at a point here? Suppose. Okay. Now this point, with this point as reference, like this point as reference, what we do? We draw a Gaussian surface, and Gaussian surface is a cylinder. Okay, it is a cylinder. Now this cylindrical Gaussian surface having three closed surfaces. This is A, and then B, means this gap, and the curved surface of the cylinder. Let me call it C. So total flux, okay, total flux means this cylindrical Gaussian surface encloses some charge, like these charges. So cylinder enclosing these charges. So that's why the flux will come out. The flux will be linked, okay, with the Gaussian surface. How much? E vector dot ds with the cylinder. Okay, keep in mind, is equals to 1 upon epsilon naught times the charge enclosed. So charge enclosed is here Q. Okay, sometime we talk about the surface charge density. Surface charge density sigma. What is surface charge density mean? Charge upon area. So charge becomes sigma into area. So if you call this area as delta S, okay, then charge becomes sigma into delta S. So charge is Q is sigma into area, sigma into delta S. So it may be written as like sigma into delta S upon epsilon naught. Now this cylindrical Gaussian surface is broken into three parts. E dot ds, closed surface at A, plus E dot ds, closed surface at B, plus E dot ds, closed surface at C. C means curved surface, is equals to right hand side delta S upon epsilon naught. Now look, here if you put a unit positive charge, it will go along this side because of the positive sheet. So this is the direction of E. And area is always a line perpendicular outward to the surface. So area vector is also along the same direction. So for point B, E and ds, delta S, they are along the same direction. Likewise here, if you put a unit positive charge, the sheet, because of the charged sheet positively, the unit positive charge will go along this side, and area is also along the same side. So here again the angle between E and delta S is 0 degree. Okay. Now coming the coiled part, here you put a unit positive charge here, it will go along this side because of the positive sheet. But the area vector is perpendicular. Area of the curved surface is perpendicular to the curved surface, like along this side. So angle is 90 degree. So for C, angle between E and DS is 90, and remove the dot product, becomes cos 90. Cos 90 is 0, so no contribution. Here angle is 0, here angle is 0, so it becomes E, and integral of ds means delta S. E delta S plus E delta S is equals to sigma into delta S upon epsilon naught. Right? Delta S cancels. Delta S cancels. So it implies 2E is equals to sigma upon epsilon naught. And E becomes sigma upon 2 epsilon naught. So this is very important. This relation shows that electrical field depend upon the surface charge density, how the charge is distributed over the sheet. One thing, E only depends upon the surface charge density over the sheet, how the charge is distributed, how much charge is distributed per unit area. And E is quite independent, like if this is a sheet, okay, this is a positively charged sheet, infinite in dimension. So I'm not showing infinite in dimension, but actually it is of infinite in dimension. You may consider the point here, or at here, or at here. E is independent of the distance of the point from the sheet, because E is only sigma upon 2 epsilon naught. Okay, E is independent of the distance from the sheet, right? And E also depend upon the medium in which the sheet is enclosed. Like if it is a free surface, free space, then it is epsilon naught. If it is the other medium, then here the permittivity will change. So electrical field due to infinite sheet, positively charged sheet is sigma upon 2 epsilon naught. And again, like if this is a sheet like this, we placed it like this, right? And what is the direction of the E? It will be along I cap. Then I'll write it here, E is equals to sigma upon 2 epsilon naught. I cap mean outward if it is positive sheet, and if the sheet is negatively charged in sheet, then E becomes sigma upon 2 epsilon naught minus I cap. Minus I cap mean if the sheet is negatively charged, then at this point the field will be along this side. So this is minus I cap along x-axis, but the negative x-axis. Okay, again the sheet is positive, and if you consider this point, the field will be along this side. So So this side is what? Minus I cap. So here A is equals to sigma upon 2 epsilon naught and minus I cap. Okay, and if the sheet is negative, and here E, direction of E will be along this side. So E will be then sigma upon 2 epsilon naught and then I cap. So it is all about that where we are finding the E and what about the nature of the charge over the sheet.